Hi, welcome to participate in Ericsson Educate Textural Game. I'm Jack from Group 10 with my group members Poovan, Prasaad and Zakaria. Are you curious about how telecommunication technology has developed in the past and become what it is now? My group members and I can bring you through the development of our telecommunication technology through these decades. No worries, there will be minimum math equations and I guarantee you can understand them easily. Alright, then let's get started.
Alright, first, how can you make a signal travel further? There is a method called signal modulation that can make it. Modulation is a simple process in which a carrier signal with constant amplitude, frequency, and phase is modified by a non-linear input signal for a better transmission. What does that mean? Let's say you have a message written on a paper that you need to send it to somebody. How would you deliver that message? Throw it straight? No, it definitely cannot travel that far. Instead, you can fold the paper into a paper plane as a carrier so your message can travel further. Low frequency signals like the human voice are incapable of propagating to a long distance on their own. When the signal is modulated within a carrier signal that has a high frequency, this modulated signal can propagate longer to provide a wider range of communication.
There are three types of analog modulation. First up, we have amplitude modulation, which is abbreviated with AM, frequency modulation, otherwise known as FM, and phase modulation, otherwise known as PM. AM was created before FM and PM, which makes AM the predecessor and also the first to be created. An AM transmitter will alter the amplitude or height of the carrier signal to change according to the amplitude of the modulating signal or message signal. On the other hand, the FM transmitter will alter the frequency of the carrier frequency according to the message signal. Similar to PM, but it alters the phase of the carrier signal instead. As FM and PM are modifying the angle component in a wave, they are also being called angle modulation. The change in the frequency of the carrier signal makes the FM system more complicated to engineer than AM. However, the FM gives a clear high-quality signal as it is less susceptible to noise interference compared to AM. This is because noise interference often manifests as amplitude spikes that can be easily picked up by AM receivers, but not FM receivers. This is why FM is more suitable for radio music broadcasting and entertainment. An analog communication system consists of a modulator, transmission medium, and demodulator.
In the early 90s, the telecommunication system was changing towards digital due to rapid advancement in fields of VLSI and microprocessors. Hence, information signals also must be changed into a digital form to be transmitted through the digital communication system. Digital modulation gives many advantages that include its immunity to noise, ease to store and processing, enabling encryption, and also error correction detection can be utilized. The analog signal will undergo sampling, quantization, and line coding first before being modulated and transmitted. An analog signal must be sampled at least at the Nyquist rate, which is twice the frequency of the message signal, to avoid aliasing. Quantization is the process of estimating the sample amplitude into a digital value that is suitable for coding, or also called analog to digital conversion, ADC. Line coding is representing binary 1 and 0 in several formats in pulse code modulation.
Next, the signal will be modulated an analogy carrier signal and suitable for the channel usage. So we know there are three techniques of digital modulation, which is include amplitude shift keying and frequency shift keying, and also phase shift keying. So we know that digital modulation is similar to analogy modulation, in which is modulating the signal very amplitude, the frequency and the phase of carrier signals. So basically, we know that the only difference is the modulating signal is a digital signals. The PSK is more often applied and it has less noise than SKA and FCK. So BSK, which means like amplitude shift keying, is also used as short bandwidth similar to SK and BSK. It represents 0 or 1 by setting the carrier of signal phase 1 to 0 degrees Celsius or 180 degrees Celsius. So we know that the other word is if there's a phase changes or carrier signal is flipped. So there is a flip of pitches. Often there is 0 to 1 or 1 to 0.
To further increase the speed of data transmission, multi-level shift keying is being used. Instead of transmitting a bit at a time, transmitting a symbol that can represent multiple bits will make the data transmission faster. A term called baud rate is used to measure the speed of data transmission. Baud rate is defined as symbol rate or symbol per second. Multi-level shift keying can be applied to every shift keying method, but the multi-level PSK has been proven to be the most useful. By using 2 bits per symbol in PSK, we will have 4 symbols in total, represented by phase change of 45 degree, 135 degree, 225 degree, and 315 degree. This is called QPSK or 4PSK. In the same manner, we can also have 8 PSK, 16 PSK, or 32 PSK. However, the probability of error will become higher as the number of levels increase. This is because symbols located on the constellation diagram will get very close together and get harder to be distinguished. To solve this problem, the communication engineer came up with the idea of combining ASK and PSK to separate the symbols further apart on the constellation diagram. Then there comes APSK, amplitude phase shift keying, and QAM, quadrature amplitude modulation. Like their names apply, they apply both amplitude and phase variation of carrier signal. With these digital modulation technologies, modern telecommunication technologies like mobile communication, Wi-Fi, Bluetooth, NFC, and satellite communication are able to function. That's all for this video content. Good luck on the upcoming quiz game and thank you for watching.